Okay, welcome all. We continue the series of MacGregor Talk here, and now we have a special guest here. And this is very exciting moment for me because usually we are talking alone here and it's somehow boring. But now we have here Miguel Saez from Hapag-Lloyd.
Hello.
So Miguel, we are going to show a little bit how MacGregor carbon calculator works, and the idea is that you will a little bit tell that how you see this result what we are going to get here. But before we are doing that, can you a little bit tell what you are doing at Hapag-Lloyd? What is your daily job there?
I would say that my main role right now in Hapag-Lloyd is to try to design our vessels the best way possible from the point of view of the cargo intake, and of course any kind of improvement we do regarding how much cargo we can take ends on my days, let's say. So basically I'm trying to get the best for our new buildings and any single retrofit that we might like to bring forward.
Okay, that's very interesting, and I think you are exactly the right person to comment on this carbon calculator because you have so much experience on that.
Thank you.
I think maybe we can change the microphone because this other microphone might be a little bit better. As a teaser here in the beginning, I would show you that now we have calculated already one case here, which comes from the MacGregor, and as you see in this corner, we have done the cargo boost case where it's possible to come up 16% points in the cargo system from 80% cargo utilization to 96. And this is for 10,000 TEU vessel, which can carry only 8,000 TEU, so quite typical case, let's say. And I want to highlight that this is not Hapag-Lloyd vessel, we just created this as our own. And now we will show that how we will get this number there by using carbon calculator. And please be aware that carbon calculator you all have access to go there. It's on MacGregor.com, so everybody can go there and play with it. So it's there for all. So if we start doing this, let's say if we come backwards first, that I take the latest rules here for the vessel input, we can see that we come 2% points down. So Miguel, what do you think if you upgrade the class rules for the vessel? How it sounds that it's 2% points more cargo efficiency?
It makes sense. It depends, of course, a lot from where to where you go. So, for example, in this case, most probably you were not going somewhere really old-fashioned to something new. So basically, 2% would make sense. So without really knowing the vessel or anything, my experience is that in a big jump, you can even get a 5%, right?
Okay, so it can be even more. So this is quite moderate. Then we check the higher lashing bridges. Now we are in 94, and it's 2% points down. So how you see this number?
This is a little bit more tricky because it depends a lot in which service the vessel would go at the end, because it will depend a lot in the cargo mix. Depending which cargo you load, you will see more or less benefit. So I would say that it's a figure that would make sense, because actually in some cases due to the cargo mix you cannot suddenly go one tier higher. So you can maybe changing the cargo mix, get a different profile of the vessel loading, winning a little bit, and again would make super sense.
Yeah.
The only thing is that in general our experience when we're doing that, we're getting a benefit of around between 6 and 8%.
Okay, so this is also a bit moderate side. But are you taking also into account that now we have here the lashings, and this we didn't change. If we come to the external lashing, then you can see it comes many percent.
Exactly. I was not considering this.
Yeah.
I was thinking in the two cases that we've done exactly what you are showing there, the change from internal to external.
Yes, okay.
Yes.
But
So
both together, then we are in
exactly. So the lesser benefit now makes much more sense than before.
Yes. Okay. Now we are in the line. Then what we were checking that this stack weight increase, it was not easy to find any let's say a difference there. But I think it comes more like because this physical improvements, they are so much better always.
In my experience, this brings a big benefit in vessels, I would say, older than 50 years, because normally they were designed considering a geometry for the lashing system with some lashing rules in which the lashing was limiting the cargo in there.
Yep.
Nowadays that this has improved so much, suddenly we have realized that if we don't get a really good stack weight, we cannot really take advantage of the improvement of the lashing in the last 10-15 years. So basically, this is something that brings I would say, quite good benefit for vessels more than 15 years old and just changing bolts.
Yeah.
For example, if we would change a very old vessel from 2007, it's a case we're investigating right now. You would change to actual rules. If we will not improve the stack weights, there is no benefit. And improve the stack weights, you get immediately a 5% benefit on the intake.
Yeah.
Yes.
Yeah. And that was good point that usually these kind of vessels, they are, let's say 10-15 years old, and we are changing those so that the new buildings, they are much more effective already in beginning. Yes, let's take the Mickey Mouse. Mickey Mouse, it's a thing from the Disney, but it also means that the lashing bridges, they have towers in the outboard side, which helps with wind exposed rows. And now we are in 87, and now we come back 1%. What is your comment?
Yeah, this kind of makes sense. Again, it's connected to the cargo mix that you carry. The good thing is that it's a 1% that in 8,000 is not so bad. We're talking about 80 TEUs.
Yes, exactly.
What happens in reality is that depending on that cargo mix, you might win residual tiers on the other stacks, because basically most part is from where these 80 TEUs are coming. The good news is that in a service in which the cargo mix allows this, basically thanks to the Mickey Mouses, you win another tier because you are reducing the wind force on the other roll, and then you see a bigger benefit when, thanks to the cargo mix, you can break this tier.
For the inner rows.
Exactly. So I would say that 1% is the automatical increase that you can get, and when the vessel is deployed in a vessel that is matching the vessel characteristics, is there on that.
Yeah, I think this is what we have been talking about, the positive domino effect. So that happens for the inner rows there. Then we have TU capacity, so mixed tow left. So now we talk about Russian tow, so we go back so that we had already in beginning mixed tow, and also in this case we cannot make so much difference, but I think it's because now sorry I was in the wrong yeah, so it's quite much now. I was thinking first that it comes from the flexibility, which you cannot measure so well. Sorry.
No, you just click on the other.
Yeah, wrong row. But what is your take on this?
Basically, I would say yes immediately, because our experience is that since our 13 TEUs order, I think 10 years ago, we decided only to build vessels with mixed tow, because originally those vessels were designed to be built without mixed tow, and we knew that due to that fact you are losing a lot of capacity, because basically the 20-footers are much more limited into lashing due to the fact that in the center of the hatch you have to lash from the bottom, and this brings suddenly an X% of tiers, based on rows and tiers that you have to bring down. So,
Yeah, it's Hapag has been the forerunner in this making the Russian stove. So now it's industry standard, but that time it was not so clear that it is the only way to go. Okay. Then if I interpret this thing, I would say that this TU capacity increase, it means that we try to find more containers under the visibility line. That makes 2%, hopefully. Let's see. Yes. Now we are back in the 80.
Again, yes. I mean, there are some cases in which we can increase the nominal capacity. In some other cases we can't, or we have to simply bring the point of view from the bridge higher, or even the lights.
Yes.
For visibility reasons, or the lights that are telling the other vessels where you are, because bringing more containers on deck is limiting a lot of this.
Exactly.
So these things are possible, but are a little bit sometimes more difficult to implement.
Okay, so we can say that if you go to MacGregor.com and testing the carbon calculator, you will have access for it. Then the results are, let's say, moderate, not anyway showing too good numbers.
They're reliable. So let's say it's not like you can say that doing everything that you just did, you're gonna get 16% or 18% that you originally had. But basically it gives a good indication of the potential. So before we were asking you to make these things for us, so we were asking you, give us, based on these vessel classes or vessel types, give us the potential based on your carbon calculator. Now we can do it by ourselves, and it's reliable. Yes.
Yeah, that's nice to hear that you can utilize this access to carbon calculator in your work.
Yes. And it helps.
Okay. Thank you, Miguel. It was really nice to talk with you.
Thank you for that.
Okay, thank you. Bye bye.